Attendees are in listen-only mode.
Hello, and welcome to the Benefits of Migrating to an IP-Based System webinar. Thank you for joining us. My name is Sandra Wendelken. I'm the editor of Mission Critical Communications magazine, and I'll be moderating the session today. Avtec is the webinar sponsor. We have some excellent information and 3 expert presenters scheduled for today's webinar. We will include time at the end of the webinar for questions from attendees, and we will do our best to wrap up the webinar in an hour to be courteous to everyone's time. Richard Brockway, president of Christine Wireless and developer of the RIC-M technology, will begin our presentation. Richard has been active in Project 25 standards since 1993, including being chairman of the TIA TR8.3 encryption committee for 4 years. He started and ran the Thales Public Safety Products Division, leaving in 2003 to start a consulting business. Our second presenter will be Russ Saveda, who is the Radio and Spectrum Section Chief for the Department of Interior. Russ manages the DOI Radio Laboratory in Denver and has more than 30 years of experience in radio communications. Our final presenter will be Carter Blumeyer, who is the Region Technician for the Federal Protective Service Headquarters in Region 4. Carter has 20 years of experience in the industry, 18 years of experience as a firefighter and EMT, and has worked on several radio upgrade projects for the federal government. Before we begin, I want to briefly explain a few of the user features of our webinar service. You will see the attendee control panel in the upper right-hand side of your screen. The control panel can be expanded or collapsed by clicking the plus or minus icons on the left side of each pane. To the left is the GoToWebinar viewer through which you'll see the presentation. To the right is the control panel where you can ask questions and select your audio mode. You'll also see an audio pane where you can select your audio format. The default is mic and speakers through your computer, but you can also click the telephone button and dial into the number that you received in your email. All attendees are muted to reduce background noise. If you'd like to submit a question for one of the presenters or myself, use the questions pane. Just type in your question and click send to submit a question to the moderator. We will reserve time at the end of the webinar for Q&A. A recording of this webinar will be emailed to all registrants and will be available at mccmag.com. In addition, Avtec, our sponsor, will make a PDF of the slides available after the webinar. So with that, we will get started. I am going to transfer the webinar over to Richard Brockway, who will begin our presentation. Richard, it's taking me just a minute to get that transferred to you.
The slide should be, first slide should be up now.
Okay. It takes just a second to transfer. Okay, Richard, I think we're ready.
Okay, I want to thank everybody for joining us for this webinar put on by Mission Critical Communications, sponsored by Avtec. We're going to be talking about the benefits of migrating to an internet protocol-based system. The first slide shows what we're talking about, where you have in this particular slide, it just shows 2 base stations that are interconnected over internet protocol, and your dispatch consoles are also connected over internet protocol. And in an actual system, there are certainly going to be a lot more than just 2 base stations. There are the benefits of the internet protocol connection. You can have very large systems with lots of interconnectivity. The benefits of an IP-based system is interoperability. You can have different frequency bands, different manufacturers, different technologies, all interconnected over internet protocol. The scalability, you can have an extremely small system, just 1 or 2 base stations and a single dispatch console, up through very, very large, even nationwide systems if you wanted to, using IP interconnectivity. It provides an incredible amount of flexibility. You could have rapid reconfiguration. You can have backup dispatch consoles, backup routing. You can put things together virtually on the fly. For instance, to respond to an incident, first responders responding to some sort of a emergency. We cover a wide geographic area. I use the word wide, but literally it's worldwide. Any place you can get an IP connection, you can put a radio service in and connect it to anywhere else, basically on the economy. The IP circuits are ubiquitous, they're cheap. It's an easy way to interconnect our public safety, first responder radio networks. You can provide any level of security that you want to on those IP circuits. We'll be talking some more about that, up to and including virtual private network AES 256-bit encryption. You can enhance the reliability of a network because you have multiple paths, multiple ways of making connections, all of which are done very transparently through the IP protocols. The difficulties in actually accomplishing this is that most currently installed legacy equipment is not IP capable and is not upgradable to IP. Therefore, you're kind of stuck with a total replacement of your existing systems. Most current IP-based solutions that are out there right now are manufacturer proprietary. They use transfer technologies, not open IP. So once you pick a solution, then basically you have to buy all of your equipment from that manufacturer. And also, most current IP-based solutions are expensive. So the solution that we're going to be talking about is the Radio Internet Protocol Communications Module, known as RIC-M. How RIC-M facilitates the migration to an IP-based system, it provides an IP gateway for currently installed legacy Motorola Astro conventional and analog equipment. This allows you to reuse your current installed equipment and not have to replace it. RIC-M uses a standards-based IP developed by the Telecommunications Industry Association, and more specifically Project 25 standards. Interoperates with equipment from multiple dispatch consoles manufacturers, 5 different dispatch console manufacturers, that's our current count, and base station manufacturers from 3 different base station manufacturers. This gives you freedom on vendor selection for buying future equipment. You can basically plug and play using the Internet Protocol, various vendors' equipment, and have the assurance that it's all going to work together. RIC-M supports a phased migration to IP as opposed to forklift migration. It maintains interoperability with your existing installed legacy systems. Installed legacy equipment in many cases has several more years of useful life. Therefore, you can defer replacement of that equipment while you're enjoying the benefits of an IP-based communication system. RIC-M puts the radio system owner back in control of the migration process, not the manufacturer. RIC-M overview. What RIC-M is, in its simplest view, is an external aftermarket protocol converter. It converts Motorola conventional Astro V.24, this is synchronous serial communications used in the Motorola Astro equipment, into Project 25 standard Internet protocol. I have to keep emphasizing the word standard. RIC-M interoperates with multi-vendor Project 25 capable dispatch consoles and base stations. RIC-M can also has the ability, if you're not using a dispatch console, you can have 2 RIC-Ms connect to each other over IP without a dispatch console. We call this the autonomous mode. RIC-M handles analog, digital voice, encrypted and unencrypted, packet data, TSBKs. TSBKs are trunking single block control, which is used for Project 25 conventional control features, call alert, and things like that. And RIC-M is configured via a web page browser. There's no special software. It's done over IP. And the remote RIC-Ms can be firmware upgraded over IP, so you don't have to travel out to each individual RIC-M to do any upgrades or modifications. The history of it, the concept addresses a requirement identified at the Department of Interior Radio Laboratory in Denver in early 2011. Department of Homeland Security Science and Technology Directorate funded the development effort starting November of 2011. We had our first live demonstration at the Department of Interior Radio Lab in August of 2012. We ran a operational field assessment test, again at the Department of Interior Radio Lab in November 2013. And then my work concluded for DHS with the final delivery of the intellectual property and the source code and the design in December of 2013. In March of this year, I received a license agreement back from DHS for that intellectual property, which allows Christine Wireless to manufacture and sell the RIC-Ms for the commercial market. We ran a DHS sponsored, and we ran a demo at IWC in Las Vegas in March. It's a multi-vendor interoperability demo. In July, Avtec received a license similar to the license that Christine Wireless has, allowing them to manufacture and sell the RIC-M. And we also, and we'll show you some slides of this, we ran a interoperability demo at APCO in Washington, D.C. in August of this year. The applications, well, I've got a slide on this, eliminates expensive and hard to get copper that is typically used to interconnect conventional Motorola Astro system elements. RIC-M can allow the addition of a non-Motorola base station like Codan, ICOM, and tape, and other equipment into a conventional Motorola Astro system, basically on a plug-and-play basis using the V.24 interface. It allows you to use non-Motorola dispatch consoles with a conventional Motorola Astro system, consoles such as those made by Avtec, Catalyst, Telex, Bosch, Moducom, and Zetron. Also allows you to relocate elements in the conventional Motorola system, Astro system, to diverse locations. You're not limited by copper or other restraints in terms of where things are geographically, because you can now connect them over IP. And the applicable products, we'll talk some more about this, include Quantar, GTR 8000, AstroTac, TIU 3000, PDR 3500. This shows the replacement of copper, just to kind of make the point of the utility here. If you had, let's say, a Quantar with an Astro modem connected over phone lines back to either a TIU 3000 or an AstroTac digital voting comparator, also with the Astro modem, those copper telephone connections are very expensive. I've heard stories of people, federal government, paying as much as $700 a month per line. Telephone companies are not renewing the lease on these things because they're transitioning to fiber optics and getting rid of the plain old telephone system copper connections. If you're dependent on copper connections, these copper connections are not transportable and they're not secure. Basically, the voice is being run over, the data is being run over open copper telephone lines. When you apply RIC-M to this particular situation, you basically put a RIC-M on each end of an IP connection. You're still able to connect both V.24, which is Project 25, voice and data. You're also able to connect analog. It's transported over Internet Protocol, comes into another RIC-M, and gets converted back into analog and V.24 to connect directly into the DIU 3000 or to the AstroTac digital voting comparator. The network options for the IP connection could be a satellite link, 3 or 4G cellular, fiber optic or cable, T1, T2. We could be the open internet or a private government internet. And for the highest security, you can do a virtual private network, which provides you end-to-end encryption on all of your IP communications. The capabilities, as I've said, digital Project 25 encrypted and unencrypted voice, also handles analog 4-wire E&M, handles confirmed and unconfirmed Project 25 data, including the OTAR messages that are transported over Project 25. Something new this year, it has a virtual COM port, which will allow you to connect the RIC-M to the radio service software plug on the Quantar or other equipment. This allows you to do anything from your desktop that you would normally do if you were connected directly into the radio software plug, radio service plug. on the Quantar. You can upload code. You can use your maintenance screens. You can change the configuration. Anything that you could do with the radio service software, you can now do over IP using the RIC-M as a virtual COM port. You can remote control the base station, change the channel, change from base station to repeater, turn monitor on and off. Already said it handles conventional control and signaling. The firmware update, when you do a firmware update, it's done as an authenticated, certified, correct update for reliability. There are username and passwords required to get into critical pages on the RIC-M, and it will connect to conventional Motorola system elements with or without a V.24 board, which gives you flexibility if you don't happen to have V.24 boards available for your Quantar or Astrotech. Once again, it can interconnect over IP from internet, private internet, satellite, cellular, and do a VPN. And all the setup and monitoring is done not with any special software. It's done with just a browser over the IP connection. The RIC-M is Project 25 standards compliant. It was built to comply with the fixed station messages and procedures document, which is TIA 102.BAHA. In addition, there's some draft documents for packet data and for enhancing the messages and procedures called BAHA-A. All those draft documents have already been incorporated in RIC-M. This allows it to handle packet data and has more flexibility in the IP configuration. This shows how your network might look with a RIC-M. You've got a pair of RIC-Ms, a RIC-M between the IP cloud and every piece of legacy base station equipment, all interconnected over IP via private network or the Capitol Internet. And your monitoring and control is done remotely over IP, as are one or more dispatch consoles in your system. The next series of slides, just to show you the equipment kind of in operation. These are taken from August at the APCO show in DC. This shows the PDR 3500, which is a transportable Quantar, a Codan base station, and a Zetron dispatch console, with the RIC-M providing the connectivity for the PDR 3500 into IP. There's another part of that table that we did that the DHS sponsored. We've got a Quantar, a Codan base station, Telex Bosch dispatch console. Once again, the RIC-M provided the translation for the Quantar equipment into IP. Next one shows the PDR 3500, ICOM base station, Catalyst dispatch console. And again, the RIC-M provides the translation from the PDR 3500 transportable Quantar into IP to allow everything to be routed. And the final part of that table had an ICOM base station, a Quantar, and a Moducom dispatch console, with the RIC-M providing the IP interconnectivity for the Quantar. The central table there, this is a complicated slide, but we had FPS in Orlando. Carter Blumeyer, who's going to be a part of our panel later on, had a setup. We ran it over a virtual private network. We had, on both ends of the link, we had the last mile done over 3G, 4G cellular. We had a router with everything being interconnected over IP on the local router and also out into Orlando. And then we used an Astrotech digital voting comparator, and as you can see from this slide, the RIC-Ms provided the translation between the green arrows, which are the V.24, and the blue arrows, which were the IP connection. We're also able to take a Codan base station and a ICOM base station, have those interconnected in the system, again with the everything being interconnected over IP, and those also were interconnected back through the Astrotech ATC 3000 digital voting comparator. It shows the cabling on that particular setup. In this case, we had an Avtec dispatch console, the Astrotech 3000 to do the voting. We had a Quantar Codan base station, all of it interconnected. The yellow lines are the V.24 out of the Motorola equipment, and the blue lines are being converted into IP. Sitting on top of the Quantar is the router, and on top of that is the cellular modem that went back out for the VPN that was ultimately came back out in Orlando. Shows a close-up of that, showing that particular setup had 7 RIC-Ms in it. The testing has been done. Marshal Service, FBI, Federal Protective Service, Customs and Border Protection, a number of federal agencies are continuing to test and evaluate RIC-M. Department of Interior Radio Lab has been instrumental and done a great deal of testing. All the dispatch console manufacturers have tested with their equipment. And there's a test report which we have a link to later on that was written from the November 2013 test at the Department of Interior Radio Lab. Availability, Christine Wireless is currently selling the RIC-M access through the DHS TACCOM contract via ACG Systems, Annapolis, Maryland. Avtec will have product available this year, and they have actually www.ricm.com as a URL which you can go to and find out more information from Avtec. And potentially there'll be other U.S. and international supply sources as DHS expands their licensing of the RIC-M technology. And finally, here are some web resources. My website, christinewireless.com. There's links into ACG in Annapolis for purchase. There's firstresponder.gov. There's continuing to be new press releases and new documents on firstresponder.gov and DHS.gov, Science and Technology. And that's the end of my slides. Thank you for your time.
Thank you, Richard, for that technology information. We'll move now to Russ with the Department of Interior. And Russ, I've just transferred the screen over to you, so we should see your screen here in a few seconds. And there we go.
Thank you, Sandy. Hello, everyone. Again, my name is Russ with the Department of Interior, and thank you for your time today. I want to start with just kind of an overview of the Department of Interior. We operate approximately 700 independent, conventional, and a couple of trunking LMR networks across all 50 states and the territories. Most of the systems are multi-vendor, whether it's dispatch consoles or repeaters or base stations, subscriber devices. We operate in a multi-vendor environment in those systems. We're also heavily dependent on others for our transport, whether it's a state and local government network, our own networks, or commercial providers to give us the transport. The Department of Interior also has a standard for these LMR systems, which is P25. Relevant to specific topics here that, the Astro equipment exists in probably 80 to 90% of those systems out there that we operate. So why is the RIC-M matter to DOI? So our experiences that we're dealing with is we have microwave networks that are migrating to digital and IP. We're doing that on our own networks, and we're also dependent on others, like as an example, the state of Arizona. As they're migrating their microwave network, we needed a solution to provide us the transport to get this back to the dispatch centers. So the RIC-M is going to play a big part in that as we started that here recently. Richard mentioned the legacy circuits, getting the copper, cost, availability, reliability. So that's a key driver for us and interest for us. The third bullet item, capitalizing on existing IP networks and that technology. We view the IP networks give us the redundant path capability to reroute things if things go wrong. We have a quality of service capability by using IP. to ensure that our radio traffic is, like priority number one, leaving any office kind of a scenario. And as Richard mentioned, we're now able to route traffic anywhere across the country over the network. Bullet number 4, we're in the process of building out our own radio IP local area networks and a wide area network. So being able to implement the technologies, the benefits of the technology, as well as that we have this LAN and WAN across the entire country, going to save us money and give us the redundancies, QoS that I mentioned. So again, the RIC-M and being able to interface to allow us to use that, the networks we're building out. There's often, as we work in these 700 systems, we're oftentimes interconnecting to other P25 standards-based systems out there, whether it's from another agency or state local government. So then it gives us the ability to take our Astro equipment or legacy equipment and being able to interface it to those other systems. The second last one, as I mentioned in kind of our background, that we live in a multi-vendor environment. In many cases, we have P25 compliant console systems, but we still have this legacy equipment out there on the network, on the infrastructure side. So the RIC-M is giving us the opportunity to migrate certain portions such as consoles and still be able to interface appropriately to the infrastructure out there. And the last thing I'll mention is extending the life of the legacy Astro and other infrastructure. Richard kind of alluded to, it gives us the ability to phase the replacements and not have to do a forklift replacement of everything at one time. And we're seeing that in lots of systems throughout the Department of Interior. I'll move on to the next slide. Talk a little bit about our experiences. As Richard mentioned, we've been involved in the development of the RIC-M from the beginning. We continue even today to test and support the development of enhancements such as multicast and QoS. We continue to do lab testing for interoperability with various manufacturers' products. Field testing, we've done, as I mentioned, the microwave network in Arizona, deploying it out there and trying it, the National Capital Region, Washington, D.C. area, to interconnect with another agency and kind of put our systems together to work more efficiently for both of us. With that, I appreciate your time. I look forward to any questions you may have, and thank you.
Great information, Russ. Thank you. I've seen Russ's radio lab. It's here in Denver, and it's very impressive. I'll transfer the presentation to Carter now. Carter, you should have your slides up here in just a few seconds. There we go. Thank you.
Okay. Thank you, and good afternoon. I'd like to thank Richard for inviting me to help speak on this project here. RIC-M, from my experience and what FPS has been trying to deal with on an ongoing basis, as most people has been alluded to in this conversation, lease circuits are a huge issue when it comes to a lot of this equipment. And Federal Protection Service isn't one of those agencies that isn't, they're susceptible to this whole project too. Again, my name is Carter Blumeyer. I currently work with the Federal Protective Service as one of their telecommunications specialists, technicians for Region 4 at headquarters. And I've spent pretty much most of my life in adult life, as I would say, 20 years plus in LMR industry as well as in the public safety. You started out as a firefighter and communication technician and unit leader with the Department of Forestry, as well as within FEMA and their Urban Search and Rescue I've done multiple deployments. I've been able to be out on the field, done installations, done integrations, and for many different agencies that was mentioned before. Most of the system integrations that we've been dealing with has been pretty much primarily old analog leased lines or circuits that were not in the traditions of IP. IP has been a new forte in the, I would say, probably the past 5 to 10 years. It's really gotten even more and more intriguing on how we can complexly put these systems together. And when this thing had come out, it had pretty much had me from the interest of how can you help agencies, how can this box specifically help agencies that we can distribute these to. I come from a small town in St. Louis, but mostly spent most of my time in Boone County, Missouri, which, for local, state, and agencies, these agencies need some way to migrate, and this box kind of really will help that out for a lot of those people out there. The Federal Protection Service is a agency that I had to really dive into looking into to figure out who they were when I took this contract with them. They are pretty much responsible for all the federal buildings that are either owned or leased by the GSA, and with that, they have approximately 200 plus LMR sites that are spread throughout the country. Some of them are voted systems, some of them are just standalone repeaters, but they're all pretty much conventional throughout the country. Federal Protection Service, they have 4 dispatch centers, they call them mega centers. These handle everything from complexities of alarms that go off in all the federal buildings to doing inspections to running records and checks and just basic law enforcement duties that have to do with these facilities that are out there. There's approximately about 1,600 law enforcement officers, and out of those officers also we have private contracts with security officers that do the metal detection, and they're usually the first people you see when you go into these buildings as a private security officer, and they're under our contracts. So with that, the system that we needed to look at as FPS when I took this position, they're in need of a transition into an IP-based system from all their leased circuits, and actually a frame relay network that was owned by GSA. These systems are outdated. They're hard to get lines for. Even today, we have problems with circuits that still fluctuate in their quality of service, and the phone company tries their best to do what they can to help us out, but they're really not wanting to deal with it, and they want us to get off of these. So with that, FPS has been trying to make a transition into a new style of IP-based systems, and how do we make that transition to make it easier for us as well as less expensive, and to be standards-based and be able to effectively, keep the cost down by competitive bidding. And so when this box had been presented, I jumped to the gun here to help Richard out and to test and vet this thing as much as we could to figure out if there is any shortfalls, how do we improve it, what can we do for it, how from integrating these things to a system level from just a standard base station, which is really what it was designed for originally. And with that, in Richard's help, he's been able to transition this box to where it needs to be today. With this, I have extensively, as he said in the presentation there, have a setup here in Orlando, Florida, which is where I'm based out of. And in FPS, we have these things called our node sites, which is where all the RF sites that are regionally located are channeled by their lease circuits to an AstroTAC comparator. That comparator then sends the signal to the dispatch centers, whichever one is responsible for that area. Currently, we had a repeater in Orlando and Jacksonville that were standalones and not connected because circuits were not available for us between Orlando and Miami, and then Jacksonville and Miami. And with that, it transitioned to to this real stable product that has helped us out into testing not only the P25 ability, the AES, the data part, OTARing, to really go back and forth with what this product can do for us. When we plan to do a modernization to upgrade our current dispatch centers, the current centers right now are proprietary based, and to make a transition, as most agencies will find out, when you try to do this, it really isn't a happy medium. It's kind of, you do all or nothing, and with agencies such as ours, that does not help out very well. So you need to do something that allows it to make it a smooth transition. And I look at this product as a definite plus for us to make a smooth transition, where we could just simply place a box at one of our node sites and then allow a IP-based standard console to attach to our old existing infrastructure. And then once the dispatch centers are replaced, we can then slowly migrate our IP sites as needed. And this is a perfect product for that. The picture I'm showing here is our current way I have a connection at our Miami node. It is running currently over a MiFi 4G, and I do have a hardline backup for redundancy. I have one box sitting in Miami, and then I have another one in Orlando, let's just say, and they're connected that way. I have not seen any degradation of quality between the 4G. I've tested it from 4G to 3G. 2G is iffy, but it'll work. I've done it over BGAN satellite, I've done it over KU, and cable modem DSL, you name it, I've pretty much made a connection establishing either VPN, AES encryption, or just RIC-M to RIC-M. With that, in playing and testing, I have come up with scenarios that the RIC-M actually can help agencies in what they're dealing with. The first scenario is obviously a console as it was designed going into a basic repeater, whether it's the P25 or analog, and that's what it was originally designed for. But you can actually use it to, as I said, connect two together to make a lease line available, get rid of it, and go to MPLS or Internet. You can take a new IP dispatch console if you need to upgrade your system, but you still want to keep your old system together. You could use a RIC-M to make that happen. You can go the other direction, where you can take an IP-based repeater, brand new standards with the DFSI, and you want to replace a repeater that's out in the field. You can then have it go backwards, where you can place it into the mix of everything, and the RIC-M will act like a Motorola V.24 device. If you have a newer style system and you want to connect into the IP of the new Motorola client cloud, they have a gateway that takes 4 V.24s to the Motorola IP. You could utilize this box where you could have a dispatch console, establish a talk group that talks to the RIC-M, and then goes into the other cloud of the Motorola and can talk to a GTR or a talk group in the trunking system, and vice versa. Within the RIC-M and utilizing if you're doing OTARing and utilizing the device, you could use it to connect DIUs to the RIC-Ms, as well as using it as a standalone connecting to an RNC 3000 if it's not positioned with the same location as the comparator. So in this scenario, when you have the configuration screen, you can take one RIC-M and the field by the Quantar and point the voice and control going to the comparator, and then the data part going to a RIC-M that's all the way over at where the node controller is. And then some other scenarios down below is basically the going back and forth between trunking talk groups. I have not experimented, I have not done the bottom one, but in theory it should work. In one of my sites, utilizing the RIC-M is just kind of getting creativity on the setups of how you can do it. The connection was for the network was down below in the ground floor, and of course repeaters in the penthouse. So you could utilize two paradigm modems or any type of modem that would be utilizing linking the V.24, and then using regular telco circuit within a building to make that kind of happen, where you could put the RIC-M and where the connection of the IP is. And that's just a layout of how I have that set up there. And then I had one other thing here. So on the screen here, these are the two configuration screens. That the one on the left over here is the site in Orlando, and it's on its internal VPN that's running AES 256 between the two locations. I'm telling it to do voice data and control. And on the other side over here is the site over in Miami where it's receiving the information, and that's just kind of how simple it is, as he was talking about on the web interface, to connect the two together. And that's just something I just wanted to show you all. Is this panel in the way here?
No, you're okay. Are those all of your slides, Carter, or do you have a few more?
Yes, that's it.
All
No,
right.
good.
Great, thank you. That's great to hear from a real-world scenario. I appreciate that, Carter. We'll move on to questions. I do have some questions coming in, and I'll just throw these out here, and I'll let the three presenters you guys will know who's the most appropriate to answer these. The first one is RIC-M approved by DHS, and is it part of the DHS approved equipment list?
RIC-M has not been, if you're talking about the approved equipment list like DHS 4300 and such, that's in process. We have not quite gotten to that point yet. Of course, DHS sponsored this program, Science and Technology, been the forefront of it, and we're pushing off in to apply to virtually every DHS agency to make this available to them and to take care of the administrative details so it's appropriate for application throughout all of DHS.
Great, thank you. Does the legacy dispatch console have to be P25 compatible?
Russ will just chime in. If you were to do RIC-M's back-to-back, one talking to the other as an example, then you could interface to an older analog console or a non-IP console. Anyone else?
No, I'd agree with that. The RIC-M's back-to-back basically provide you a transparent analog connection from one end to the other.
Great. Is configuration via the SNMP version 3 supported? And are usernames and passwords via the SNMP version 3 supported?
SNMP is part of the stack, if you will, the TCP/IP stack that's built into RIC-M. RIC-M, as it's currently being deployed, these are not configured. There's something in SNMP called a MIB, and the MIBs have to be customized for the particular application. But the RIC-M and the stack that's inherent in it are SNMP v3 capable, including usernames and passwords.
Okay. Is the RIC-M compatible for out-of-country response, for example, deployment for disaster relief?
I'd say absolutely yes, it is. Basically, because you have the total flexibility of getting a connection via any data circuit that you can support IP over, it's a natural for things like disaster relief. We've had some testing done at FEMA MERS, Mobile Emergency Response Service, and there is a move afoot to start equipping some of the FEMA MERS in the future, hopefully, with the RIC-M to provide quick recovery and disaster response using an IP backbone.
Okay.
I can just chime in on that too, where this has actually been utilized as a go down the road aspect, where you could take a portable PDR 3500 or a portable Codan, and as long as you have a 3G, 4G, or BGAN data connection, you could actually put this within a convoy and continue to have your communications back to your nest or your point of origin.
Okay, great. How does the RIC-M control the remote base station, the non V.24 station? tone control, or audio hard keying?
Right now, the only capability built into the RIC-M for remote control is the V.24. Typically, the V.24 commands that go into, let's say, a Quantar would arrive as a tone remote from the Centricom dispatch console, and the DIU would convert those tones into a V.24 command. The RIC-M actually produces those same V.24 tones, but does it based on an IP command. So there are, in fact, Carter showed one earlier. There's a screen there which allows you to change channel, change base station repeater, turn monitor on and off. And those don't involve tone remotes, but they do involve control of the base station via the V.24.
Okay, great. With redundant connectivity, how does the RIC-M decide which connection to use? Does it test for QoS or absence of a connection?
It would test for absence of a connection. It depends on what the RIC-M is doing. There are heartbeats that are sent back and forth between two connected RIC-Ms or between a RIC-M and a dispatch console. And if those heartbeats two heartbeats are missed, then basically it goes back into looking for a reconnect. So if your backup system came online after the primary system stopped operating, it would reconnect in a matter of seconds and reestablish communications automatically.
And that would either be done either through a Cisco router or PepLink or Cradlepoint, which you would have your redundancy built in on that separate device, not within the RIC-M.
All right, great. The next question is whether it supports a digital system.
It does support digital. I'm not sure about what the nature of the question was. It supports both analog. It does support P25, P25 encrypted and unencrypted. It supports confirmed and unconfirmed data. It supports TSBK's conventional control. It does the full range of Project 25 digital communications in addition to supporting on the same IP link 4-wire E&M analog.
But it does not do DMR or next edge, any of those types of protocols.
Okay, great. One question is where the attendee could get full documentation. I'm assuming, product, full documents on the product.
I have a link there, christinewireless.com. There's a number of things on there, slide presentations. There's a PDF on there. And there's also additional information that's on your screen right now at www.ric-m.com, which is the Avtec website. In addition, on my slides, when you get a chance to see them, there are, and in fact on christinewireless.com, there are hyperlinks into DHS documents. And you can click on those links and it'll take you to DHS PDFs and flyers and things like that on the DHS and firstresponder.gov websites.
Okay, great. Yeah, there seems to be a lot of places to go for more information. Which IP protocols does it use between units? TCP, UDP, unicast, or multicast? And then IPv4 or v6?
Right now, the TIA standard has not been extended to IPv6, so it is IPv4. The standard relies predominantly on UDP for the connectivity between RIC-M and a console or between two RIC-Ms. Then, of course, the web pages that are supported within the RIC-M for control and monitoring are your traditional TCP/IP.
Okay. Another question, does the RIC-M have wireless connectivity built in?
RIC-M, actually, I did build a few that did have Wi-Fi cards built into the box, but people would be using an external router. That external router could have a Wi-Fi capability on it. I connect in my office, in my test lab, routinely over Wi-Fi just from the router converting from the Ethernet connection into Wi-Fi.
Okay, and then can the unit be used for Tetra networks?
No.
No, okay. Let's see, what else? There's a question about encryption enabled on the RIC-M. Is there encryption within the product?
There's not encryption within the product. The product, if you're using an encrypted signal, it's totally P25 encrypted. It's totally transparent. Things like encryption sync and like that are passed over IP without decrypting the signal, and all the sync and algorithm IDs and things like that are passed through on the UDP data stream. The only encryption that's within the product is a cryptographic sum that's done to authenticate the firmware before it's uploaded. The firmware is checked for integrity, and also that it came from the appropriate source before it's loaded into the box. So there is a cryptographic protection on the firmware upload. That's the only cryptographic capability built into the box.
If your V.24 is encrypted, then the packets obviously are going to be encrypted going across. But if you need to encrypt the IP part of it, then yes, you'll need some sort of an external cryptographic device to make that IP base encrypted. And but if you're using a newer base console and you're utilizing the RIC-M as a link to a V.24 signal that has the encryption, you do not need a digital interface unit at the other end to decrypt it. The console standard for IP should decrypt it when it reaches the console for the end-to-end encryption.
Okay. How much latency processing delay is added? This person who asked the question is concerned about comparators with multiple types of transport.
We've done very little latency testing. Basically, the signals in and out of the RIC-M are processed and shipped out over IP as soon as they're received. So once the entire, let's say a 20 millisecond frame is received, it's pushed out over IP. We've seen no noticeable latency or variables over the IP links, even over ones running thousands of miles. You've got a fixed delay, and it just seems to be not even noticeable from a voice service.
What I can say for that, an experience, if you're trying to utilize this as a simulcast connection to repeaters to the comparator, the latency would be too much for that. Right now, when I would do link delays in a comparator, I would get anywhere between 60 to 80 milliseconds, which would be too great for a simulcast. A voted system, if you're using a vote scan in sites that are multiple cities, it shouldn't affect that as much. And I've utilized it in vote scan systems.
Okay, another question about redundancy. Is there any other way of creating redundancy other than having a spare device?
I think go ahead, Carter.
Yeah, you're probably correct. The redundancy within the RIC-M, if the RIC-M were to go out on you, yes, then a second device would be needed. And if you're utilizing the dual ports on the front of the Quantar, you could trick it into an RT mode and then have that redundancy that way. But having the two connections at the same time, I don't know. I haven't experimented that. You'd have to log in and make that second connection, or at least have it on a standby external device ready to go if you lost a link. But the RIC-M will talk to each other. If it loses the V.24 signal on one end, it will send a heartbeat signal to the other box to drop the V.24 so that your link light on the other side will tell you that you have lost a connection. Because when you do plug these boxes in, originally the V.24 link would be established, but there was no way of knowing before if the other side of the house you lost your link on the one side. Now it does that. It also will do it if it loses the IP connection between the two. If you're using them to link up, it'll drop the heartbeat for the V.24 and start blinking your link light there.
Okay. Another question about, are the units DC powered, 48 volts?
The unit is powered by we supply it with a 12-volt wall adapter. It takes slightly over about 150 milliamps at 12 volts, and it can be supplied by virtually any 12-volt supply that you might have handy.
With
Okay.
the latest RIC-M, if I'm not mistaken, Richard, won't it run on, if you're running V.24 only, if you plugged in the ribbon cable to the wireline card and didn't have a V.24, it would run off the wireline card?
Yes, the later version of the RIC-M, if you're using the ribbon cable, but you can see some more about that at the PDF on my website. Use the 50-pin ribbon cable to plug into the plug that the Astro modem would normally be connected into. The RIC-M can actually be powered off the 5 volts on that plug from the Quantar. It doesn't require any external power.
Okay. Can the RIC-M be configured for multicast operations?
Multicast operations is something we're currently talking with Department of Interior and other users about. In principle, yes, it's be a firmware upgrade, a software upgrade. We're trying to figure out how the user would like to use a multicast capability for real-world applications. Once we come up with a requirements document, we intend to move on to implementing that into a future upgrade. Having said that, I would like to point out that RIC-M has been a moving bit of firmware for the last several years. Every time a user comes along with a new requirement, we've been able to upgrade the firmware and then release that firmware to everybody and have all the boxes that are already out there be upgraded to handle the new capabilities. And we're very pleased. Just this last week, we just added the quality of service feature that allows the RIC-M to require the highest level of quality of service off the IP. And that was something based on some suggestions from the Department of Interior. So we are going to continue to evolve the RIC-M firmware to meet the user requirements.
Okay, and then I have a couple questions here about cost of the product.
I'm going to defer the cost comments. You can go to the Avtec website, www.ricm.com, or to christinewireless.com, and there are links on purchase there. And I think one of the complications are if you're buying through a GSA or a U.S. government contract, it's a different pricing than if you're buying it commercially. So I think I'd refer people to the two websites.
Okay, great. Well, we still have a few questions, but that's about all the time we have. If we didn't get to your question, we'll work to get the answers and follow up as soon as we can. And again, a recording of this webinar will be emailed to all registrants, and it will be available at mccmag.com. Further questions can be directed to the email address that you see there up on your screen, aboulware@avtecinc.com. And a thank you again to our presenters and attendees and to Avtec for serving as the sponsor. This concludes our webinar. Have a great rest of your day.